Hopefully I'm not radioactive, so hopefully this is working, but it doesn't appear it is.
No, that's just the screen.
Just the screen,
yeah.
Okay. Lovely, thank you. So I'm just going to give you a very high level overview of our project working with National Highways at the moment. So the project, we're working in association with WSP and also Amy as well. So we've heard about an off-road GLOSA slip project already. This one is slightly different. So we're actually looking at trying to predict and understand the traffic flow so that we can influence drivers on a mover-enabled junction. So most of what we've seen at the moment has been on Scoot. There are GLOSA systems on mover, but what we're really trying to do is provide speed advice and accurate speed advice to the drivers. So the main objectives of the project, I mean, first of all, can we actually predict what mover is going to do next based on the dynamic traffic flows? Second of all, can we affect the driver's behaviour? Unfortunately, in this instance, I mean, the intention is to provide GLOSA to HGV drivers. So junction 23 of the M5 is basically the main entry and exit point for the hauliers going out of Hinkley Point C, the new nuclear power plant build. So you can imagine lots and lots of traffic and substantial benefits if we can affect their driving behaviour, reduce fuel expenditure, and obviously emissions on the environment as well. So there's a couple of ways that you can look at data, and we've used data in a variety of different ways at Zircon. So we've been involved in looking at enforcement using video analytics, slightly associated. We've also looked at speed detection as well from using video analytics. So what we're actually trying to do at the moment is we're building a machine learning algorithm which is taking the SPAT data, so signal phase and timing data, and it is able to predict the next step that the move algorithm is going to take based on the dynamic traffic flows. So we've been doing machine learning work now for about the past 5 or so years. We've taken Bluetooth journey time data sets to predict traffic flows. Like I said, we've done video analytics, and now we're looking at trying to build an algorithm to predict the traffic flow. So as you can imagine, this is an innovative project. It's relatively, as with all innovation, it comes with an element of risk. So we took a really kind of pragmatic and logical approach to move the project forward. So initially, we actually started looking at the learnings in Europe, what BMW have been doing, looking at other methods for taking machine learning and building algorithms to predict state of the road network. So looking at the different approaches across the world, we were able to simulate a significant amount of signal phase and timing data using PTV Vism, and that was really WSP's kind of aspect or input into the project. So taking the simulated data, we've heard a lot about simulation and its benefits. Okay. So simulated data, we split that into 2. We basically use one lot of simulated data to build the algorithm, the second lot to validate it, then went across and did the development, the testing, and now we're actually at a point where we've got real world data, and we're processing that through the algorithm that we've developed to see if the results are equivalent. So just finally, we've had really great success in being able to predict what the next step of mover is from using the simulated data. We've actually got 85% accuracy, providing results only 84% of the time. So really the key here is when you're providing the information to professional drivers is to limit the false positives. So if we can't provide advice, if we can't accurately predict, we just don't provide information. And that way, people have confidence in the system when it is providing the information necessary. So I think that's about my time. If you've got any questions, please let me know. Contact details are up there.
Thank you very much.
Lovely. Thank you.